This is 7.3 unit circle. The first subsection of this section is finding trigonometric functions using the unit circle, and this is from OpenStax Algebra and Trigonometry book. So we've defined trig functions in terms of right angles, and that was, if you remember back, that was the fun little saying we had. Right, we had SOHCAHTOA. Right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So we've learned how to do that with right triangles, but the trig functions can also be defined in terms of the unit circle. So let's real quick review what that means. The unit circle is a circle centered at the origin with a radius of 1. So if I sketch a coordinate plane here, the origin would be where the x and the y axis meet, and if I say that this is y is 1, x is 1, y is -1, x is -1, the unit circle would be the circle that hits all those points, and of course I didn't sketch that very well, but you know what a circle would look like on that. And so that is the unit circle. The intersection of the terminal side of the unit circle can be labeled by its, the intersection of the terminal side of the angle with the unit circle can be labeled by its coordinates. So if I put an angle on here, let's just put this one, then where that terminal side of the angle intersects with the unit circle, that location can be given the coordinates x, y, right? So it would be x, the x value would be from the origin to this place, and the y value would be from y equals 0 up to that place. But using our knowledge of SOHCAHTOA, we can come up with a trig identity for these coordinates x and y. And so what we see is that the cosine, let's call this t, cosine of t, cosine is adjacent over hypotenuse, so the adjacent would be the x, is x over hypotenuse, and because this is the unit circle, the hypotenuse is 1. So therefore the cosine of t is equal to x. Similarly, we can say the sine of t is opposite over hypotenuse. The opposite is the y value over the hypotenuse, which is 1, and so the sine of t is equal to y. So we could say that this distance here, that is sine t, and this one here is cosine t. Try to get that in there really small. And so that's how we can define the trig functions using the unit circle. Real quick, I just want to take note that depending on which quadrant it is, you're going to have different values for x and y. So in quadrant 1, you're going to have a positive x, and you'll have a positive y. Quadrant 2, you'll have a negative x and a positive y. Quadrant 3, they'll both be negative, negative x and negative y. Quadrant 4, you'll have a positive x and a negative y. That's going to come in useful later, so keep those things in mind. So let's go ahead and formalize our definition. If t is a real number and a point xy on the unit circle corresponds to an angle of t, then we have that cosine of t is equal to x, and we have that sine of t is equal to y. So that's what we showed on the previous slide, but now we're just formalizing it as the definition of sine and cosine functions related to the unit circle. And so here we can see this is the same thing that we drew out before. So our x and y coordinates of this point, at the intersection of our terminal angle with the unit circle could also be written as cosine t sine t. Okay, so keep that in mind. Let's go ahead and do an example together. It says point P is a point on the unit circle corresponding to an angle of t as shown in the figure. Find cosine t and sine t. Okay, so we're going to find cosine t and sine t. From our previous slides, we know that cosine of t is equal to x. Okay, so all we need to do is look at our x coordinate here. Our x value is 1/2, which equals 1/2, and that would be our answer for cosine of t. And sine t corresponds with y, which in this case is square root of 3 over 2. Square root of 3 divided by 2. And that is the sine of t. That's all you need to do. You just need to look at the value of your x and your y to find sine and cosine of t. Okay, so let's go ahead and let you try this. Pause the video, try this on your own, and then come back and see if you did it correctly. Okay, let's go ahead and read it. A certain angle t corresponds to a point on a unit circle at negative square root of 2 divided by 2 and square root of 2 divided by 2 as shown in the figure. Find cosine of t and sine t. So once again, we know that the cosine of t is equal to the x value. In that case, it's negative square root of 2 over 2. And then we have the sine of t is equal to y, which in this case is square root of 2 over 2. And that's all we have to do. When given the x and y coordinates, we can just identify the cosine and the sine from the x and y coordinates. So check the answer that you wrote down, make sure it is correct. If yours doesn't match mine, make sure you go back and rewatch that part that explains how to do that so that you understand how to get the correct answer. Okay, quadrangle angles. Remember, quadrangle angles are angles on an axis. For quadrangle angles on an axis, the sine and cosine can be found from the values of x and y. So I'm going to go ahead and sketch our coordinate plane here. Okay, let me switch color here. And so let's look at the angle that, let me go ahead and make my line a little thicker here. So if we had an angle that was on the positive x-axis there, that would terminate on the unit circle at point 1, 0, which means that in this case, the cosine of t, cosine is the x, would be 1, and the sine of t is the y, and that would be 0. Let's take a look at a quadrangle angle on the positive y-axis. So that point would be at 0, 1, which means the cosine of t would be 0, and the sine of t would be 1. And then let's look at the negative x-axis. That would go here, and that means that point, the terminal side point, is at negative 1, 0. So the cosine of t is equal to negative 1, and the sine of t is equal to 0. And then lastly, the negative y-axis there, that point would be at 0, negative 1. So the cosine of t at that location would be 0, and the sine of t at that location would be negative 1. Okay, so you can easily find the sine and cosine of quadrangle angles just using the x and y coordinates. Now, you can figure it out. It is useful to have these memorized. As you use them more, they'll probably stick in your head because we'll use them quite a bit. So let's look at this example here. It says find cosine of 90 degrees and sine of 90 degrees. So let me go ahead and sketch this, and let's grab a different color here. So we are talking about this angle here. Okay, so here's our angle T. And so we need to find the sine and the cosine. So let's identify our x and our y. Because this is a unit circle, we know it's only 1 unit long. The x is 0 and the y is 1. Therefore, the cosine of 90 degrees is equivalent with the x, which is 0, and the sine of 90 degrees is equivalent with the y, which is 1. So that's how you find the sine and cosine of 90 degrees. The next one, try it, number 2. Find cosine and sine of the angle pi. So now we're working in radians. Go ahead and pause the video, work it out, and see if you get the correct answer. So let's start by sketching out our coordinate plane, and then I'm going to switch to a different color here to show our angle. We're talking about an angle of pi, which means it would be this angle here. Okay, so it's pi, and the would hit the unit circle, to intersect the unit circle at -1, 0. Okay, so we can use that to find our cosine. The cosine of pi is the x, which is -1, and the sine of pi is our y, which is 0. So check your answer, make sure you got the same answer as I did. And if not, go back and rewatch how to determine that. The next thing we need to talk about is called the Pythagorean identity. And I know you guys all know what the Pythagorean theorem is. The Pythagorean theorem states that a squared plus b squared is equal to c squared, and we've used this to find the sides of triangles. But now we're going to relate it to the trig functions on the unit circle. So the Pythagorean identity. What we need to do first is we need to go back and we need to review what the equation for a circle is, and specifically the unit circle. So the equation for the unit circle is x squared plus y squared is equal to 1. X squared plus y squared is equal to 1. Anytime you have a circle, you're going to have your x and your y variables are going to be squared. And then on the other side of the equal sign is the radius squared, but 1 squared is just 1, so we don't need to have that square there. And so that is the equation for the unit circle. We also need to keep in mind that our x and our y, we know what those are trigonometrically. X is equal to cosine of t, and y is equal to sine of t. So then when we take all 3 of these pieces of information here, we can plug them together into the Pythagorean identity. So if we have that x squared plus y squared is equal to 1, but we know that x is cosine of t, we can plug cosine of t in for x in the equation of a circle, and we can plug sine of t in for y in the equation of the unit circle. So we're going to end up with cosine of t squared, but we actually write the squared after cosine, so it's going to be like this: cosine squared of t, okay, so that's our x squared, plus sine squared of t, that's our y squared, is equal to 1. And this is the Pythagorean identity. Cosine squared t plus sine squared t is equal to 1. Now, if you remember, when we're solving equations like this, getting our values of x and our values of y, they will yield 2 answers. They will yield 2 solutions, a positive and a negative, because when you take a square root of something, you have to take the positive and the negative. So why do we use this? If it's going to give us two solutions, but we only have one, well, one thing we can do is we can use this to find the cosine if the sine is known, and we can also use it to find the sine if the cosine is known. But we just still have that problem of two solutions. More information is needed to choose the correct solution. So for example, if we know which quadrant, if we know which quadrant is in, that will tell us which of our solutions we're going to use, right? Remember back on the first or second slide, we said that this quadrant you have positive x and negative y. In this quadrant you have positive x, positive y. In this one you have negative x, positive y. In this one they're both negative. And in this one you have positive x and negative y. Okay, so if you know what quadrant it is in, then that can help you choose which solution you are looking for. So let's go ahead and do an exercise with that so you can see what I'm talking about. It says if sine of t is equal to 3/7 and t is in the second quadrant, find cosine t. So I'm going to go ahead and sketch this out. And I know that t is in the second quadrant. Remember, this is 1, 2, 3, 4. So I know that it's in this quadrant. So I'm going to go ahead and just sketch a generic angle there. I don't know if that's correct, but it doesn't really matter because I'm just sketching it out. So then I know that the sine of t is 3/7 and t is in the second quadrant. Find cosine of t. So I'm going to go ahead and drop a right angle to the axis there. Here's my t. Okay, and then I know that the sine is 3/7, and sine corresponds to the y value from the axis. So I know that this is 3/7, and I know that this is cosine of t. I don't know what that is yet, but that's what I'm trying to find. I'm trying to find the cosine of t. And so I'm going to use my definition of the unit circle. Cosine of squared t plus sine squared t is equal to 1. And then I'm going to plug in what I do have. I have that the sine of t is 3/7. Cosine squared t plus 3/7 squared is equal to 1. I'm going to simplify. Cosine squared t plus 9/49 is equal to 1. Now I want to move the 9/49 to the other side, so I'm going to subtract 9/49 from both sides. Cosine squared of t is equal to 40/49. And then I want to get rid of that squared, so I need to take the square root of both sides. Cosine of t is equal to, now remember, when I take the square root of both sides, I need to do plus and minus the square root of 40/49. Okay, now I need to simplify this even further. I don't want a bottom number of a fraction to be square rooted, so that's going to be plus and minus the square root of 40 divided by, and we know that the square root of 49 is 7. Okay, so now I got rid of my radical on the bottom, but I still have a radical on the top that can be simplified even further, and that is plus or minus square root of 4 square root of 10 divided by 7. I'm going to come down here, and I know that the square root of 4 is 2. Square root of 10 cannot be simplified any further. So my solution, I have two solutions. I have the positive 2 square root of 10 divided by 7, and I have negative 2 square root of 10 divided by 7. Well, which one am I talking about? Which one do I actually want? Remember, we're finding the cosine of t. We're finding the x value of t, and we know that it's in the second quadrant. Okay, so in this quadrant, what are my x values? Are they positive or negative? they're all negative. So I know that the actual solution, even though there are two solutions here, the actual solution that we are looking for is negative 2 square root of 10 divided by 7. That's my solution. Okay, so knowing which quadrant is in is going to let you know which solution you want. Okay, so here's one for you to try. If cosine of t equals 24 divided by 25 and t is in the fourth quadrant, find sine of t. Go ahead and pause and try this on your own. If you need to, go back and watch the example that I just did and follow this one step by step, replacing it with the information from this one, and then come back and check your answer. So the first thing I'm going to do is I'm going to sketch this out. Okay, and I know that it's in the fourth quadrant, so I'm going to draw a generic angle in the fourth quadrant there. My angle is T. We have 24 over 25. So I know that this is the cosine, which means this is going to be the x value, 24 over 25, and the y value is what I don't know, but I know that it's sine t, and that's what I'm looking for. Okay, so let's go ahead and use the Pythagorean identity in order to set this up. So I have cosine squared t plus sine squared of t is equal to 1. I have the cosine, so I can plug that in. It's going to be 24 divided by 25 squared plus sine squared of t is equal to 1. And then I'm going to go ahead and square both of these. When I square 24, I get 576. When I square 25, I get 625 plus sine squared of t, and that equals 1. I'm going to move this fraction to the other side in order to isolate my sine squared of t. So I'm going to subtract 576 625ths from each side. So I get sine squared of t is equal to 49 over 625. Now I need to square root both sides to get rid of that squared. Sine of t, and then keep in mind I have to do the positive and the negative of 49 over 625. Okay, this one is nice because 49 is a perfect square. 49, the square root of 49 is 7, and the square root of 625 is 25. So the two possible solutions are positive 7 over 25 and negative 7 over 25. Which one do we want? We're in the fourth quadrant, okay, and we're looking for sine. So sine is the y value. In the fourth quadrant, is the y value positive or negative? It's negative. So we know that the solution to this is negative 7 over 25. The positive solution is extraneous and we don't need it. Okay, if yours did not match mine, go back through it and make sure you understand it. Go check Google Classroom for your assignment. If you have any questions, please do not hesitate to ask me.